Let's go ahead and get started here. My name's Nick Wagner. I'm a program manager on the input and composition team. I joined Microsoft about 8 years ago as a developer in the Windows deployment team. After that, I moved over to the security division where I worked as a program manager on internet scale web services. But for the last few years, I've been back in Windows, working on everything from touch-optimized controls down to the depths of the input stack. Today, I want to talk to you about how you can move your existing desktop app forward to take advantage of the input stack so that you can make your app pop with touch, mouse, and pen. Now, I want to start by actually walking you guys through a demo. The idea of this demo is we're going to take an app that has just mouse and keyboard support, and then throughout the talk, we'll actually show you how you can extend it to use touch and pen. So let me jump over to that. All right, so this app actually already has all of the pieces wired into it, but I want to show you the mouse and keyboard support first. And so what you're seeing here is a very simple annotation scenario. You can imagine this in anything from an insurance company where there's a claim form to fill out, to the medical industry where you have doctors looking at patients' files and x-rays, or in our case where you've got a advertising company that's looking at photos that they might use in their next marketing campaign. When the customer first comes in here, what they can do with their mouse is they can go ahead and click on this button. They can click and drag to create a note, and then they can enter some text with the keyboard. After that, they can go ahead and move it around. Now, the very first thing that we're going to do today is we're going to actually wire it up for touch, and we're going to go beyond just that single mouse cursor. So you'll see me here creating a note with touch, and now I can actually touch down with 2 fingers and move the items around. After that, we're going to go ahead and take a look at panning and zooming. And so we'll show you how you can get the experiences and personality that you see in the rest of the system, like this bounce effect that shows you that you're at the end of the content, or the zoom that you see that sticks to the finger. And then last, we're going to go ahead and take a look at the pen. And we'll show you how you can add support for ink to let your customers just write directly on the notes. And so you'll see here, oh, I didn't click the button. You can see here that I'm writing with my pen. And then once that's complete, I go ahead and click the button, and that ink is actually converted into real text. So let me go ahead and close this out. Let's jump back over to the slides. All right. As we go through this talk today, we're going to start out near the bare metal, and we're going to work our way up to the more semantically meaningful gestures. We'll start by taking a look at how you access input and some of the key concepts and methods around its program model. We'll also spend some time taking a look at touch hit testing and how you can use it in order to make touch more reliable in your app. Next, we're going to go ahead and take a look at what the Windows touch language actually is and how you can use it to make your app feel more natural and intuitive. We'll show you how to use an interaction context so you can quickly incorporate that language into your app. Now, a key aspect of touch is panning and zooming. If you stop to think about it, nearly every app has some form of it, whether it's panning through a document, through the items in the list, or zooming in on a photo. It's nearly everywhere. We'll show you how you can use the direct manipulation APIs to get that stick-to-the-finger experience that your customers will love. And finally, we'll take a look at the pen. We'll show you how you can build an experience where the ink actually flows right out of the tip of the pen, and we'll show you how you can use the handwriting recognizers so that in your app, the pen can do more than just simple drawing. Now, before we go too deep, I actually want to take a step back and take a look at where desktop apps are today. Now, the first desktop apps were created almost 30 years ago. And over those 30 years, together, Microsoft and developers like you have been on an incredible journey. We've seen apps go from the simple, basic forms they took back then to being sophisticated tools with deep and mature functionality. We've seen them go from being used by just a handful of customers to being used by more than 1 billion people around the world as part of their daily lives. Now, while we've been on this journey, you guys have built an amazing and diverse ecosystem. You've built everything from note-taking software to audio, video, and media editing, to workflow management, to communication software, to even portals into new worlds. Now, so far, desktop apps have been primarily mouse and keyboard based. And while we've been on this journey together, we've made mouse and keyboard precise and efficient. The mouse and keyboard are still good input devices. They have a number of advantages. The mouse is great for that precise, detailed work, and the keyboard is great for rapid text entry. But customers' expectations continue to evolve. Not only do your customers want that precise and efficient input, they also want that natural and intuitive input that is being ushered in by a wave of new form factors. Now, I want to share a couple of my own experiences around this. A couple of years ago, I had my first chance to use a pen with a tablet. I got a contract and an email that I needed to sign. Always before this, I would have had to print the contract out, find a pen, sign the document, find a fax machine, and finally send it off. It was simply a thrill just to flip the screen around, sign the document, click a button, and be done. With touch, I found that my expectations have actually risen. Every now and again, I find myself at home playing with an app that hasn't been designed for touch. It really drives me nuts when I can't click the button I want, and it's even worse if I click the wrong button and something bad happens. So why do I bring all this up? Whether it's a tablet, a clamshell, a desktop, or an all-in-one, your customers are going to get used to using touch and pen. Now, you could wait until your customers get frustrated and they give you the feedback that your app doesn't work quite the way they expected, or you could capitalize on this opportunity and you could build for your customers one of those thrilling experiences. Now, historically, we've been spending a lot of time since Windows 8 talking to you guys about how you could build great store apps. But in order for the technology to be available to make those great store apps, we've made investments up and down the platform. Those platform investments are available for you to use in your desktop apps. Now, hopefully, you had a chance to watch James's Clark earlier today on powering up your desktop app with Windows. There, he actually introduced a number of these platform investments. So the part that we're going to spend our time on today is actually these input interaction pieces. As I mentioned in the agenda, we're going to start at the very bottom of the stack with the WM Pointer APIs. We're going to walk up to panning and zooming with the direct manipulation. And finally, we'll move over to pen with the real-time stylus and the handwriting recognition. All right, so let's get into the nuts and bolts. WM Pointer was introduced in Windows 8 as a way to unify the different pointing devices. If you're familiar with coding against WM Mouse, you'll probably recognize, or at least some of these messages will feel familiar, with things like WM Pointer down, up, enter, and leave. So what does WM Pointer do for you? It allows you to code for pointer once and get an experience where touch, mouse, and pen all just work. Now, in order to be able to code just once, you need to actually route mouse through your pointer. And you do that through enable mouse and pointer. Now, your default reaction should be to go ahead and just do this, but there's a few cases where you may not want to. So for example, if you have a bunch of code that is relying on peek message and it's looking for WM mouse, or if you have a bunch of code that's heavily relying on set capture, you may want to just leave that code as is rather than rewriting it. Once you have the pointers, you're going to want to get more detailed information about it. Let me see here if I can advance the slide. All right. And the way you do that is through get pointer info. And it provides you information like what type of device did this come from? Was it a touch, a mouse, or a pen? What is the screen coordinates? It also provides a unique identifier as well as a handful of other properties. Now, if your app can't process the messages as fast as they're being generated, those messages can be coalesced into a single update message. Now, the way you get access to that coalesced data is through get pointer info history. And so this is important in a couple of scenarios. For example, if you're trying to use velocity for something, you probably actually want the velocity, the actual instantaneous velocity, not just the average velocity across those coalesced data. Or if you're trying to draw a circle, you're going to want to get all that data in between so you can draw a nice smooth curve and not one with jagged lines. Now, get pointer info provides the information that is common across the different pointer devices. But the system provides APIs to allow you to get device-specific information as well. And that's through get pointer touch info and get pointer pen info. Now, for the pen, this provides information like the tilt of the pen as the customer is actually writing, or the pressure that they're putting when they're drawing. With touch, it gives you information like the contact geometry and the orientation of that geometry. And now, that's actually an interesting point. The pen actually shares some of the same benefits of the mouse, and the fact that it's good for that precise pixel-by-pixel work. However, with touch, in contrast, when the finger comes down on the screen, it actually covers a number of pixels. And that brings us to our next topic, hit testing. In order to more accurately determine what your customers are trying to touch, hit testing needs to take into account the contact geometry. Now, if the app that you're building is primarily window-based and the controls you're using are window-based, then the system already takes care of this for you. But if you're doing your own hit testing, then the algorithm I'm about to describe can dramatically improve the reliability of touch in your app. Now, let's run through this algorithm with an example. What you have here is simply just 2 buttons being hosted inside of Control-C. Now, the very first thing you need to do is you're going to need to go ahead and find the window that these are hosted in and register to participate in hit testing. And you do that with that API call there. Now, from this point forward, when a finger comes down on the screen, you're going to get a WM Touch hit testing message. Now, one of the interesting pieces of data on this is actually the bounding box on that message. And this is a different bounding box that you'll get than if you tried to call get pointer info. And the reason for that is during hit testing, we actually want to take things like occlusion, if another window is over yours, into account so we can figure out what your customer is touching. Once you have that bounding box, you need to go ahead and look at what controls intersect it. So in our case, that's button 1, button 2, and Control-C. Once you have that list, you want to go through the Z order. Anything that's further back in the Z order, you want to discard so that we're really looking at the controls in the foreground. Now that we've done that, that will eliminate Control-C. So we've got button 1 and button 2. And what's left is we need to evaluate which control is closer in proximity to that contact. And we're going to do that by using these 2 API calls. Evaluate proximity to rect, or you can use evaluate proximity to polygon. Now, what this returns is actually a struct. And one of the values in this struct is a score. And this will help us go ahead and pick the right value. In our case, that'll be button 1. And once we've got that, we'll go ahead and make a call to pack touch hit testing proximity evaluation, and we'll return the value from that from our message handler. From this point forward, the system has everything it needs to be able to actually adjust the point that's being reported and all of the subsequent WM pointer messages. And so in our case, that point will actually be represented on button 1. And so all the rest of your code can just work as it is. All right. So we've gone through some of the fundamentals here. Let's go ahead and jump over to a demo here, and we'll go ahead and look at the code. All right, so before I jump too far into this code, let me give you a little high-level overview of what's going on here. There's really 3 classes in play that we're going to be looking at today. There's a window class where all of our message handlers are going to actually be. There's something called the sample engine. And the sample engine is the one that's responsible for kind of all the heavy lifting. It's the one responsible for creating the notes, or at least triggering the creation, tracking where all the notes are, and then finally routing input to those notes. And then last, we're going to go ahead and have an annotation element itself that represents the note. And it will do some processing the input in order to move itself around, as well as storing the text and then drawing the ink later on. All right, so let's go ahead and look at our message handlers. What I've done here is I've gone ahead and just kind of left the mouse code in that was already there and commented out so I can show you the before and the after. All we've done here is we've gone ahead and updated from our down, move, and up handlers, our messages handlers, to pointer down, pointer update, and pointer up. And you'll see we've also registered for this WM Touch hit testing. We'll go ahead and take a look at those in a moment, but first we want to do one more initialization piece. Let's go ahead and clear that out. And so what you can see here is we're in our run call. And we're very early still in our initialization. And what we're doing here is we're going ahead and we're actually enabling mouse and pointer so that as we use the mouse, we'll actually get those pointer messages. The other thing we're doing is we're registering for hit testing, and we're passing this parameter in. And this parameter just tells the system that when the finger comes down on the client area, we actually want to get a WM Touch hit testing message. So let's clear that breakpoint. All right, and so now we want to go and take a look at our actual handler. So let me give it a little bit of input. And so you're in the pointer down handler. And what you'll see is we're actually getting the X and the Y, and this code remains unchanged. But the first thing that we've commented out here is set capture. And so what this was for is when the mouse button came down, if the customer drug the cursor out of the window, we wanted to keep getting messages. We don't have to do that anymore because it's implicitly done on our behalf when we're listening to the pointer messages. Beyond that, it just went ahead and passed it along to down. But we have to do a little bit more work now. So previously, we were getting all of our coordinates in the client coordinate space. But with pointer, we're actually getting them in screen. And since we're trying to go ahead and reuse most of our existing code, we want to go ahead and convert that from screen down to client. The last thing that we're doing here is we're actually going to go ahead and use this macro to pull the ID out. And we're going to use that for two things. We'll use that to actually track some of the associations between the contact or the finger itself, as well as some of the elements that are moving around. The other thing that we'll use it for is to kind of make those deeper calls into get pointer info so we can find out more about it. All right. And so now let's go ahead and look at the sample engine itself. By the way, I skipped over the update and up handlers because it's basically that same set of code. So it's boilerplate. We're just literally walking through it, so I don't want to repeat it for you. So now we're into the sample engine. Like I said, this is the guy that's responsible for actually knowing where all the notes are and doing some of that heavy lifting. So previously, we were just checking to see if that button had been clicked, and then we were going to try to create a note. Now, for our customers, trying to create multiple notes at the same time doesn't seem like something that's going to be very easy for them to manage. So rather than doing that, we only want to allow one contact to create it. And we're going to do that with the primary one, or the first contact that comes down on the screen. So let's go ahead and take a look at this isPrimary. It's just a little helper function. And you'll see what it's doing is it's going ahead and calling getPointerInfo, and then it's just simply looking at the flags to find out if it's primary. Very simple, very straightforward. We can jump back here. If we are in this case, we'll go ahead and add the element. The next part of the code is what happens when a finger actually comes down on one of those elements. And so what you can see is when we had a single mouse cursor, we can make some assumptions about having only one element that can be interacted with at a time. We need to go ahead and extend that code so that we can actually have multiple elements being moved around. And so that's what we're doing here. I'm going to jump around a little bit here. So what we're doing is we are going ahead and creating an element map, and this is what allows us to track the contacts and all of those elements that are actually being manipulated. We'll go ahead and pass the information onto the element itself so that it can go ahead and process it, move it around. And this is more or less the same code as you saw right above. And the last thing is we're actually walking through all of our elements to check to see if they're already being manipulated. If they are, we're going to go ahead and return, which just means that we're going to ignore any of the other fingers that come down on it. Now, this isn't the best experience for your customers, but we'll show you how to actually go beyond the single finger per element experience in the next section. And so the last thing I want to show you here is actually the hit testing itself. And so let me go ahead and add some input so we can see it. So we're in the actual hit test method. We're passing in a client matrix so that we can actually move things back up to screen coordinate space. And the primary thing that we're going to do here is we're going to walk through all of our elements to see if our contact geometry actually intersects it. So that's what we're doing. We go ahead and get the D2D geometry, and we'll use that to go ahead and check the Z order a little bit further below. We're going ahead and getting the bounds of the control itself in screen coordinate space, and then we're making that call to evaluate proximity to rect, and this is how we're going to figure out how close it is. We're going to make a call to D2D, which is compare with geometry, and it's going to fill out this relation parameter. And we're going to use that to figure out which one is higher in the Z order. So basically, if these guys overlap, the guy that comes later will always be higher in the Z order. And that's just by definition of how we've constructed our visual tree. And then finally, we're going to do our comparison. So if it's our first time through the loop, we'll go ahead and update what our best control is. If it's higher in the Z order, we'll go ahead and update it. And then finally, if it's just a better score, we'll update. After that, we'll go ahead and make our call to this method. We'll return the value, and we're off to the races. So let me go ahead and clear this out. And so with that, that's all the code it took. Whoops, clicking the wrong buttons. There we go. I'm drawing ink now. All right. Well, let me rerun this here so I'm not clicking all over the place. Let me add one note. Let me add another note. And now you can see we've added the code. We can actually move it around. That second finger is actually being ignored. And then I'm not very good at intentionally, accidentally missing the control. So let me see if I can show this to you. There, I did it on the first try. You can actually see here that the center of that contact is not actually on the control. And so we've actually updated that point, and we're actually interacting with it. All right. So let's jump back over to the slides. So when we set out to reimagine Windows 8 to be a touch-first operating system, we spent countless hours watching, observing, tweaking, and measuring how customers interacted with the system. What we ended up with was a set of 7 simple gestures, which we call the Windows Touch Language. Now, those 7 gestures allow customers to do everything with the system. But not only are these the natural and intuitive and easy to learn gestures, but more importantly for you, it's the gestures that your customers have already learned. They're already using these gestures to interact with the start screen, with IE, and with the store apps. So by using this language in your app, your customers can take what they've already learned to immediately and intuitively know how to use your app. If we take a look at these 7 gestures, you can actually split them up into 2 separate classes. There's the static gestures, the things like tap and hold, where you want to find out what your customer has done once they've done it. So for example, with hold, you want to find out when your customer has put their finger on the screen and held it there long enough, and you also want to know when your customer has lifted their finger off the screen and that hold is complete. In contrast, there's the manipulations, the slide, the pinch, the rotate. And now when your customer is doing these, you're going to want to know what your customer is doing while they're doing it. So if a customer slides their finger across the screen, you're going to want to know how far that finger is translated each step along the way. Now, the way that you integrate the touch language into your app is through the interaction context. It does much of the heavy lifting for you. It's based off of WM Pointer, and it's a math engine. And it analyzes that input in order to detect the gestures from the touch language. Once it detects that gesture, it goes ahead and extracts the relevant information about that gesture for you. So for example, if your customer rotates their fingers on the screen, it'll do the work to figure out the angle that the customer has rotated through. Now, in our example here, we're going to wire up an interaction context to each one of the notes. And to do that, there's kind of 3 phases that we're going to walk through. The first one is initialization. And so going through this, we're going to go ahead and create an interaction context, and then we're going to go ahead and configure it. And the primary things that we're going to configure on it is really what type of gestures do we want to detect. And then last, while we're initializing, we're going to register our callback. And this is how we're going to actually know when a gesture has occurred so that we can actually respond to the output. Next, we need to feed input, and we're going to do that with these 2 API calls here. The first one here is add pointer. And so what that's doing is, let's imagine a customer puts 5 fingers down on the screen. If only 2 of them come down on our notes, we only want those 2 contacts to be considered when we're looking for a gesture. Add pointer is the way that you tell the interaction context which pointers it should be looking at. The next is we're going to actually feed the pointer frames into the interaction context, and we do that with that process pointer frames call. So what is a pointer frame? So if we go back to having 5 fingers down on the screen, some digitizers will actually report all of that information as a single unit, and that's what we're referring to as a pointer frame. So we're going to take that pointer frame and hand it off to the interaction context, and then by having it as a frame, it can actually process all of those deltas and movements, ups and downs, as a single unit, rather than trying to do it one by one. Finally, we need to actually handle the output itself. And this is the signature of our callback here. The first thing you'll see is a little bit of client data, and so that's just being passed back to you when you register your callback. And then finally, there's a struct here that actually tells you more about what's going on with the gesture. Now, that's pretty critical, so let's take a deeper look at it. So this is the information you're going to get, and the first thing you'll notice there is the interaction ID. The interaction ID is what's going to tell you which gesture is occurring. Is it a tap, a hold, or a manipulate? The interaction flags will tell you whether the gesture is begun, ended, or is in inertia. And the input type will tell you what type of device, so touch, mouse, or pen. Now, the X and Y actually correlates to the center point of a gesture. So if you're rotating multiple fingers on the screen, the X and Y will be the center point between all of those fingers. There's a few more detailed arguments where you can get some more information. We're going to be using the manipulation one in our talk, or in our demo today, so let's look at that. And what you're seeing here is actually 2 transforms. The first thing that you're seeing is 2 transforms. The first one is a delta, and that's very useful if you're already storing off a matrix and you just want to update it. Or if you've got a hierarchy of elements and how you want to apply the changes could actually change based off of what's happened. And so in our example, when we wire up panning and zooming, we'll have exactly that. We'll need to take into account the transform that's applied due to panning and zooming so that we can correctly apply this delta so that the thing actually moves under our fingers. If your app is a little bit simpler and you don't have those constraints, the cumulative one is provided for you as convenient so that you can just grab it and set it. The velocity actually returns all of the information on a per axis basis. So this will give you information about the translate X, translate Y velocity, the expansion velocity, as well as the angular velocity. And then finally, there's this Rails state, which I haven't talked about yet. So what is Rails? Rails is a feature that actually helps your customers, when they're trying to translate, lock to a specific axis. So for example, if they're trying to move a map around and they're trying to go exactly east and west, if they lock to a rail, even if they move their finger up and down, it'll go ahead and just move east and west. And so that's a feature that you can go ahead and enable both on the interaction context as well as later in direct manipulation. Now this rail state just informs you whether or not they've actually locked to that rail or if they're still allowed to kind of move it in any direction they want. All right, so let's go ahead and take a look at the code to actually integrate the interaction context into our app. All right, and so I'm going to go ahead and run this. And we'll go ahead and step through some of the interesting code. So we're actually going to create our interaction context when we draw the note. So let's go ahead and click down here. And you'll see that we're just creating some resources. So we're just building up some of this interesting kind of data members to drive the notes around. The first thing we do, just like we said, was create an interaction context. Next, we go through and we actually configure it. And so in our example, we're going to set the configuration so that we can get all of the manipulations. So translate X, translate Y, rotate, and scale. And then we're also going to look for tap. We'll go ahead and set that configuration. And then we're going to actually set a property on the interaction context as well. And that's this filter pointers property. And this is what tells the interaction context to expect that we're going to be calling add pointer so that it knows that it's going to need to filter out some of those pointers. We go down and we do our final step during initialization. We register our callback. Excuse me. And what you can see here is we go ahead and pass ourselves in as that client data so that we can get back to our instance. And we just pass in our static callback. All right. So let's go ahead and create one of these notes. And let's go ahead now and let's try to start going through that feeding input phases. Oh, this always happens because timing in my app with debugging. So let's do this again. Here we go. And now let's go ahead and jump down. So what you can see now is we've actually down in the annotation element itself, and we've got the on-down handler. So before we were using the interaction context, the annotation element was doing all the work to track the previous point and then do the math to actually figure out what transform to apply. We don't have to do that anymore, so we can go ahead and comment out all that code. We're going to make our add pointer call so that the interaction context knows to track that pointer. I'll walk you through these other ones real quick. The on update, we don't have any work to do in here because the interaction context is literally doing all the work. And then finally on up, we'll go ahead and remove that pointer from the interaction context so we can keep its state up to date. Next, we need to go ahead and process the frame history. And so we're just in a little helper function here that calls in when it gets a pointer of any kind. And so what you'll see here is that there's actually 3 steps. Our first call to get pointer frame info history, we're not going to pass in any variables for it to actually fill out those frames into. And so all we're doing here is we're getting the counts so that we know how much memory to allocate for those pointer frames. We go ahead and do that here where we create our array. Next, we'll make that same call, this time passing in our array so that we actually have those pointers now. And then all we have to do is hand those off to the interaction context. The last thing we need to do is we need to actually take a look at the output itself. So let's do that. Here we are in our static output callback. We passed ourselves in, so we're just going to cast ourselves back to an annotation element. And then we're going to jump down into the instance member function as well. Here that is. And so we're going to switch on the interactions. So depending on if the customer is tapping or manipulating, we'll have 2 code paths. If they tap, we're simply just going to go ahead and change which element's focused. If it's manipulating, we're going to go ahead and call this member function around manipulate. Right now, you're seeing all of the different parts of that transform broken out. The only thing that's interesting to note here is that our system and the rendering code that we're using works in degrees, where the interaction context works in radians, so we're doing that conversion. Let's jump into the manipulate call real quickly. So this call here is the one that's doing all of the work. I'm not going to walk through it, but all it does is it looks at the transforms above it, it takes in all of those deltas, and it calculates the transform that you should actually apply so that it moves under your finger. We go ahead and we set that transform, and then we call draw, which will actually commit those changes. Let me clear that guy out, and that's it. With that, you can go ahead, you can pan it around, you've got the rotate, you've got the zoom. So we've gone well beyond that single finger experience in that last section. So one of the first things that your customer is going to do when they get to your app is they're going to try to pan and zoom. Now, often your customers, in the very first few touches of your app, they're going to decide whether your app is good or great. So how do you make a great panning and zooming experience? Now, the way you do that is by using direct manipulation. Direct manipulation is the system component that drives panning and zooming in everything from the start screen to IE to the store apps. It uses the direct and intuitive gestures of pinch and slide to allow customers to control panning and zooming. Now, not only does it drive the panning and zooming, it also encapsulates the panning or the personality of the system. So it allows you to get nice effects, like the inertia effect when your customer slides their finger across the screen and lifts up. It provides that nice, smooth inertia animation. The other thing it provides is things like bounce effects. So if your customer is sliding their finger along the screen and they hit the end of the content, rather than having it feel like they've ran into a brick wall, they get that nice, smooth behavior of it bouncing off and then animating back. The last thing there's things like snap points, and this actually allows you to have some control over inertia. So let me give you a couple of examples. Let's say that you're building a reading app and you actually want to allow your customers to pan one page at a time. The mandatory snap points will give you a nice inertia curve so that as your customer pans, it'll actually snap one page at a time. Or let's say that you're building a newspaper app and you actually just want to have headings and a lot of text. The proximity or optional snap points will provide an inertia curve that makes it easier for your customers to land on those headings, but it won't force them to stop. So the way that direct manipulation works at the highest level is you need to pre-declare all of your behaviors and interactions before input comes. And so what do I mean by that? Let's walk through an example. Let's say that we have the start screen itself. And so what does it need to declare? Well, the first thing it needs to declare is kind of the viewport. My clicker is not working, so bear with me. All right, is the viewport. And so this is the thing that your customers can actually see. And so for an example of the start screen, this is actually the full screen itself. The other thing it needs to declare is actually which direction the content should be allowed to scroll. And so for the start screen, this is just horizontal scrolling. Next up, it needs to declare the content itself. And so you can think about the content as all of the tiles that are in the start screen. And so this content that we're being described to direct manipulation is kind of the bounds of that, so it knows how much stuff is actually there that it can pan and zoom through. With this information, direct manipulation actually has all of the information it needs to process input on your behalf to drive the panning and zooming. So that means as input comes, it can actually do those calculations. Now, direct manipulation has been designed from the ground up with performance in mind. So when it is processing input on your behalf, it is actually doing that off of the UI thread. Now, you could get that output transform, marshal it back to the UI thread and apply it, but direct manipulation really starts to shine when you couple it with direct composition. Now, direct composition allows you to create layers within your content. And among other things, it allows you to apply transforms to your content. Now, when you're doing that work, or when direct composition is doing that work, it is actually also doing it off of the UI thread. And so what this means is if you couple direct manipulation and direct composition together, you can actually create a pipeline from the input stack to the output stack that is free to respond no matter what your UI thread is doing. So for example, if your app is busy running complex logic or doing layout and rendering or whatever it needs to do to get the job done, your customers can still get a great responsive panning and zooming experience. All right, so now let's take a look at what it's going to take to integrate direct manipulation into our app. There's kind of three phases that we're going to walk through again. The first one is initialization. And the first interface we're going to go after is the direct manipulation manager. Now, this is the factory object that allows you to create all the rest of your objects. It also has an activate and deactivate call on it. And this just informs direct manipulation whether you want it to process input or not on your behalf. From there, we're going to go ahead and create our viewport, that thing that kind of describes what the customer is allowed to see. And then off of this viewport, we'll go ahead and we'll configure which directions we want the content to be allowed to scroll. After that, we'll go ahead and add the content itself. And now we've got everything that kind of informs direct manipulation about what you want, but we still need to associate an input stream to the viewport. And so we need to look at hit testing. Now, the way you actually do that association is through set contact. And so if you have a complex hierarchy of elements, what you're going to want to do is you're going to go down to the very deepest viewport that's in your element tree. You're going to call set contact on that viewport, and then you'll want to walk up your tree calling set contact on every viewport it finds. Now, the reason why we want to do this is it allows direct manipulation to create a hierarchy of these viewports dynamically at runtime. Now, this is important for a couple of features. The first feature is chaining. So to describe it, let me walk you through an example. If you have a scroll view that is allowed to pan hosted inside of another scroll view that can pan, and you've enabled chaining, when a customer touches down in that child, when they reach the end of the content, it'll go ahead and chain up to the parent so that the parent starts to pan. Another thing that's interesting is gesture targeting. And we refer to it a lot as parent promotion. And so an example of this is if you have a scroll view that can only pan, hosted inside of something that can zoom. If your customers put their fingers down on that child and do a pinch, we actually want gesture targeting to kick in and to promote that input up to the parent so that the thing actually zooms. Now, the thing that triggers you to do this hit testing and to call set contact is there's two methods. There's the WM pointer down, and then there's the DM pointer hit test. Now, DM pointer hit test is a new message that we're introducing in Windows 8.1. Hopefully you saw James's talk earlier today where he was demoing that new input modality, the precision touchpad. There's a number of improvements that we're making around making those touchpad feel great, but the one I want to focus on is how it made the panning and zooming feel buttery smooth. The way that you bring that buttery smooth feeling to your app is you listen for WM pointer hit test, you integrate direct manipulation, and you call set contact. Direct manipulation will then provide that experience for your customers. And then the last thing I want to talk about is what happens when a pan or zoom actually begins. And so when it begins, you're going to get this message called WM pointer capture changed. Now, the best way to describe what this message is for is through an example. If you have a button that's hosted inside of a scroll view, when your user's finger comes down on the screen, you're going to immediately want to show feedback that button is depressed. Now, when the pan actually begins, you're going to reset its state so that you can tell your customers that it's not going to be clicked. WM pointer capture changed is a message that triggers that and lets you know that you need to go ahead and reset its state. All right, so let's go ahead and look at the code now and look at direct manipulation. Here we go. We're going to just immediately jump right in. And so what you can see here is we've added this little helper class to wrap some of the calls. And then we're in this method called setup direct manipulation. And so we're going to walk through kind of that initialization workflow now. We'll go ahead and we'll create our direct manipulation manager. After that, we're going to go ahead and this block of code is actually starting to do the work to tie direct manipulation and direct composition together. So what you'll see here is we're creating this object called decomp manipulation compositor. And what that is it's a wrapper around direct composition to kind of make tying those trees together easier. And the primary thing that we need to do here is we need to go ahead and take an update manager and pass it to it. Now, the update manager would be the API that you would call if you wanted to manually tick forward direct manipulation's internal state. So, for example, if you've got inertia running and you want to find out what its current value is, you would tick it through the update manager. Since we're using this direct manipulation compositor, we're just going to pass in that update manager, and it's going to do all of that work for us. Next, we're going to go ahead and create our viewport. And you'll see that here. We're going ahead and we're enabling all of the different manipulations on it. So translate X, translate Y, and scaling. We've also turned on inertia there. And then we're going to go ahead and set the size of the viewport itself. Now, the last thing that we're going to do with the viewport is we're actually going to add an event handler to it. And so this is going to tell us what the actual transform is that's being applied during panning and zooming. And we'll use that transform to keep track of where all of the objects are, or all those elements are, so that we actually can route the input to them and do our hit testing. Next, we're going to look at the content. And so we're going to go ahead and make this call, which is get primary content. The reason why we call it primary content is if you think about it, there's a couple of different things that move on screen as you're panning. You've got the content itself that the customer touches down and moves, and then you have things like the scroll bar. The scroll bar we want to actually move as well, and we refer to that as secondary content. Off of our primary content, we're going to go ahead and set some boundaries. So this is just constraining the zoom to 100 to 400%. We're going to also set some zoom snap points so that if the customer stops in between and lifts their fingers, we'll get a nice inertia animation that guarantees we stop at either the 1 or the 4. And then last, we'll go ahead and set the content direct, and we're done with the content. Finally, we'll go ahead and we'll enable that viewport, and we'll activate direct manipulation. And that's that primary initialization phase is now complete. We have one more thing we need to do now, and that's this associate demanip. And what this is really doing is we're finishing that association between direct manipulation and direct composition. And that's happening in this add content call. And so what's happening under the covers is you've got these two visuals that are passed in. Direct manipulation will insert a visual in between these two, so that as it sets a transform on it, it doesn't stomp on any of the transforms that you've already set. With that, we've actually completed the ties between, and direct manipulation can now talk directly to direct composition. So we have that pipeline set up. So let's go ahead and clear our breakpoints. And then the last thing I want to show you in this demo is that hit testing piece, so that we're actually associating through set contact. And so what you'll see here is we've put a little input into the system. We're back in our sample engine down handler. We've already done the work to know that we're not creating a note. We are not manipulating an element. And so the only thing we have left is this check. And this is a little bit of policy that we've defined for our app itself, which basically says that if a customer is already manipulating an element, don't let the panning or zooming start. Now, this isn't the only policy that you can implement, and there's a couple of different techniques and tricks you can use with direct manipulation in order to actually have it manage this for you. But in our case, we're just going to go ahead with this simple policy. You'll go ahead and see the set contact call, and it's just a wrapper that then hands it off to the viewport and calls it. Now let me go ahead and run this code. And now what you have here is you've got the actual direct manipulation up, and it's running in here. So right off the bat, you can see I'm getting the bounce effect where my finger is slipping on the screen. I'll show you that again. When I zoom in, I can stop halfway, and it goes ahead and animates. Now you see that the content is pixelated, and I want to talk a little bit about that with you. Direct manipulation is just applying a transform to your content to scale it up. If you want to go ahead and have sharp content, when you're listening in that event handler, you need to go ahead and respond and then re-rasterize your content so that you actually have more pixels on the screen. And that will go ahead and correct this. In this demo, we didn't want to go ahead and complicate the code too much, so we just left it very simple. But that's something that you're really going to want to consider for your app. And then last, I want to go ahead and show you some of this inertia so you get that nice, smooth inertia curve. Let me go ahead and close this out, and we'll slip back over to the deck. All right. And so before we move on to the pen, I want to make one more point, which is as we've been wiring up direct manipulation into our own UI frameworks, we found that our UI thread can sometimes be busy enough that that initial start to a pan or a zoom feels slow and sluggish. The way we've addressed that is we've added a feature that allows you to do hit testing from another thread. And so that's going to move us to a 3-threaded model. We've got the first thread, the UI thread, where we've been doing all of our work. We've got the delegate thread, which direct manipulation creates on your behalf in order to process input. And now we would need to create a third thread in order to do the hit testing. Now, the way you get that input, the WM pointer down and the DM pointer hit test, is through this register hit test target. Once you've got that data, you're going to need to do the hit test, and you're going to need to do one of two models. You can either create a shadow copy of your display tree, where you have all the information that you need to do the hit test, or you can implement granular locks so that both the UI thread and the hit test thread can access that information without either of them blocking too much. Now, neither of these approaches is trivial. So I encourage you to go ahead and take a look at your experience to measure that very initial latency, and that way you can decide if you need or want to go down this route. All right, so onto the pen. The pen marries the best of touch with the best of the mouse. It brings together the direct and intuitive nature of touch with the precise and detailed interactions of the mouse. Now, people often think about the pen on a computer much the same way they do in the real world. Sometimes they'll use it as a tool to go ahead and press buttons, but primarily they use it for their ink so that they can draw and write. Now, in our app, we're going to go ahead and allow customers to do that natural interaction by just simply writing on those notes. And then we're going to use the built-in recognizers to go ahead and convert that ink into actual text. So the way that you build a great inking experience is through the real-time stylus APIs. Now, a key aspect to that great experience is latency. When you draw or write, you actually make minute little adjustments as you move up the pen on the paper. And the real-time stylus APIs provides a mechanism so you can process input off of the UI thread. That tight feedback loop for your customers is critical in order for your app to feel great. Now with Ink, you also have powerful tools with the recognizers. And so what this does, it allows you to go beyond just having pixels on the screen so that you can actually do something semantically meaningful with that ink. So let me give you a couple of examples. Let's say your customers are actually students. Wouldn't it be great if they could just scribble margins or scribble text in the margins of their textbook, and then later they could come back and search and actually find their handwritten notes? Or let's say your customers are engineers. Wouldn't it be great, as they wrote their formulas that they use as part of their everyday lives, if you could actually recognize those formulas and do something that was useful and helpful for them? All of this is possible with the recognizers that are built right in Box. All right, so looking at how the real-time stylus goes into our app, there's, again, 3 things that we're going to look at. We'll have the initialization. And so the first interface we'll go after is the real-time stylus. Now, the model around this is that you can have a number of plugins that you add to the real-time stylus, and these plugins are chained together. So it allows you to actually create some very complex and sophisticated scenarios if you choose. Now, we're going to go ahead and create a synchronous plugin today, and we're going to do that so that we can do that input processing off the UI thread. And so the API that will be, or the interface that we'll be implementing is the iStylus Sync plugin. Now, there's a bunch of methods here that I'm not showing, but the ones that are really interesting to us are the stylus down, the packets, and stylus up. And this is very similar concepts. So the WM pointer down, the pointer update, and the pointer up. Now, during these handlers, what we're going to be doing is we're actually going to use D2D to render our ink. And so we'll create a path geometry, and then we will go ahead and allow that to be rendered out. Now, the other side of this is we want to go ahead and start getting the recognizers and so that we can actually look at the handwriting. And so to do that, we're going to need to go ahead and create strokes. And so what you see here is a stroke builder, and we'll use that inside of our implementation of the synchronous plugin. And that'll be, the methods that we'll be using there are begin stroke, append packets, and end stroke. And when we end the stroke, we'll actually have access to a real stroke that we can then hand off to a ink recognizer context. And from that, we can actually do the recognition. Now, there's a couple of concepts here. There's recognize itself. If you call this method, it's synchronous. And if you have a lot of ink, this can be computationally intensive. So we also provide a background recognize method. The alternates is also an interesting concept. So if your customer's handwriting could be recognized as multiple different things, these alternates allow you to build an experience where your customer can pick what the right thing is. So before we jump into the code, I actually want to walk you through kind of all these pieces again graphically so you can see how they fit together. So let's go ahead and look at that. So the first thing we're going to do is we're going to go ahead and we're going to implement a synchronous plugin. Inside of that synchronous plugin, we're going to go ahead and use a stroke builder. Once we've completed our implementation, we'll take that plugin, we'll insert it into our real-time stylus. And then after we've processed enough input and we actually have strokes, we'll hand that off to our ink recognizer context. And with that, let's go ahead and take a look at the code itself. So the first thing I want to show you here is the handler itself. And you can see a few factory methods. Here is the synchronous plugin methods that we're interested in, the stylus down, up, and packets. We're also implementing this data interest, and it basically just informs the real-time stylus API which methods we actually want to have called back on. There's a number of other interesting information that you can get. However, we're not going to use in ours, so we just have a trivial inline implementation here. All right, so let's go ahead and take a look at the initialization. And so what you can see here is we're actually in a create sync event handler. So this is kind of a static factory method here. And we're going to go ahead and create our handler. We'll add it to our synchronous plugin. And then I want to point out one more thing here, which is this window input rectangle. Now what this does is you can actually tell the real-time stylus APIs to look at a subset of the window so that it's not actually looking for ink across the entire window. And so in our app, we're going to be very simple, so we're going to give it the full window, but you have the option to scope that down to either the control area or something more specific if your app demands. So let me go ahead and clear that guy out. When we go ahead and we'll create the annotation here, we will add some ink. And so this is the last bit of initialization we're doing. So we're actually enabling the real-time stylus at this point. We're going to go ahead and create a stroke builder so that each time we are kind of doing that handwriting recognition, we're just starting from a clean slate. And the last thing you'll see here is this show window. And so what we're actually doing is we're popping up a transparent window over all of our content. And this is what real-time stylus is wired up to, so it can actually get that input and feed it back to us. So let's go ahead and look at our implementation of those down, update, and up. So let me draw a little text. And so what you can see here is that the very first thing that we're going to try to do is we're going to go ahead and begin our strokes so that we're going to have them to be able to do our handwriting recognition. And some of the information it needs is from this get packet description data, so we're just kind of plumbing that through. Next, we'll take a look at the drawing code itself. And so the real-time stylus APIs actually work in its own coordinate space. And so what this block of code here is doing is it's just converting from that coordinate space into the coordinate space of that transparent window, and then finally into our content window itself. And then finally, we're going to make this call draw Bezier from points. I won't walk through this, but this is just basically tracking the points that are fed to it so that it can create that D2D path geometry, and then it'll render. I'm going to skip over the update because all it does is this coordinate transformation and draw Bezier. But let's take a look at the up. So the first thing is we'll do that same call again, but now we're going to actually end the stroke. And so that's what we're doing here. We have a little bit more code to do, but then what we're getting out of here is the actual strokes that the customer drew. And then we want to go ahead and push that over to the recognizer context. Let me step into that because this is just lazy created here. And so what you have here is I'll walk you through this at the highest level. This block of code is basically getting all of the default recognizers that are on the system, or all of the recognizers that are installed in the system. It then gets the default recognizer with the default language on that second line, and then finally it just goes ahead and creates that recognizer, stores it off, and hands it back. So with that, we've gone ahead and we've done all of the work to push it over to the recognizer. There's one last thing we have to do, which this happens because of timing in my app, so let me restart it here. We've got this. Let me add a little ink. So I'll write my text. And then when we click on the Add Ink button again, we actually want to do the handwriting recognition. So we can look at that. We're just first checking to make sure we actually have ink, so we check that first statement here. We'll get our recognizer context again. We're going to go ahead and call end ink input. And so what that's doing is it's just telling the recognizer to go get all of its internal data structures ready to go do the actual handwriting recognition. And then finally here, we're going to do the recognition itself, and then we're going to actually get that text string out. And then finally, we'll just go ahead and set that text string. And with that, I'll go ahead and run it, and I'll show you. It's converted to text. All right. So that's all it took to wire up ink as well as handwriting. So let's go ahead and go back to the deck now. So as we've talked today, I hope you've noticed that when I've been speaking about panning and zooming and now ink, I've talked a lot about latency. Performance is absolutely critical to these two experiences. Under the covers, both direct manipulation and the real-time stylus APIs are using the same feature to get input off of the UI thread. And because of that, you can't use direct manipulation on the same window as real-time stylus at the same time. So as you're building your app, you're going to want to think about which windows you wire up to direct manipulation and which windows you wire up to the real-time stylus APIs. And then you're going to want to think about how you manage the transition between them. In our app, we made that transition very explicit by allowing the customer to click on that Add Ink button. But in some workflows, you can actually make that implicit and make it seamless. All right, we've talked a lot about a lot of things today, so let's go ahead and do a quick recap. We talked about how you could use WM Pointer to move your app forward so that you can make an experience that just works with touch, mouse, and pen. We talked about how you could use the interaction context to be able to incorporate the Windows touch language into your app and how you could use that language to make your app feel more natural and intuitive. We talked about how you could use direct manipulation to make that stick-to-the-finger experience complete with the personality and effects that you see throughout the system. And finally, we took a look at the real-time stylus APIs as well as the handwriting recognizers so that you can make your app pop with Pen. Now, there's a number of resources here if you want to learn more. I've got a talk on exploring custom touch interactions for your Windows Store app. That was a video talk. All of the concepts that I talk about there apply to the desktop as well. There's just a little bit of API differences. If you're interested at all in direct composition, I highly recommend you stick around. Silvana will be talking in this room right after this on direct composition. There's a number of reference documentations here. There's a direct manipulation sample that should have gotten posted today. And then there's the touch target guidelines, which should actually walks you through how big your controls should be so that your customers can have confidence as they're actually touching your app. The code that we walk through today will be posted up near the slides in the video in the near future. And then beyond that, thanks for listening, and I look forward to seeing how your apps evolve with Touch, Mouse, and Pen.